Hi friends, we are asked to find the shortest distance between this point 3 by 2 comma 0 and this curve y equal to root x. Right. So let us take a random point on this curve and try to calculate the distance between this random point and this point 3 by 2 comma 0. Right. Any point on this curve, any point on this curve, if will have this format, right? What is the format? Y square and y. X would be equal to y square, xy would be something like this. If y is y, x would be y square because root of x, root of y square is actually equal to y. So for example, if y is 2, right? If x is 4, y is 2. Root of 4 is 2. X is 9, y is 3. What does that mean? If y is 3, x is 9. If y is 4, x is 16, whatever. If y is y, x would be y square. Right. So now we have y square comma y and the distance between this 3 by 2, 0 to this point. Right. So then it would become, let us assume it is y1 square and y1. Then y1 square minus 3 by 2 whole square plus y1 minus 0 whole square, which is this. This is the distance. If we expand this, it will become y1 whole power 4 plus 9 by 4 a square plus b square minus 2ab. 2 into y1 square into 3 by 2. Right, that 2 and this 2 will get cancelled. So minus 3y y1 square plus y1 square. What is this y1? y1 is some random point. Right, some y1 square and y1, some random point on this curve. This curve looks something like this. Y equal to root x is a curve which looks something like this. Okay, so now we can see it, this equation has translated to y1 power 4 minus 2y1 square plus 9 by 4. Now let us complete the square. Okay, this is in the form of p square minus 2p plus 9 by 4. Right, where p is equal to y1 square. Let us complete the square. How do we complete the square? P square minus 2p plus 1 minus 1 plus 9 by 4. Right, because this will become a perfect square. P minus 1 whole square. Right, this will become perfect square and we had to add 1 and subtract 1. So net net we are not adding anything. So 9 by 4 minus 1 which will be equal to 5 by 4. Right. So this has become p minus 1 whole square plus 5 by 4, which is y1 square minus 1 whole square plus 5 by 4. Now, when y1 is equal to 1, this becomes 0. This is a perfect square, so it can't be lesser than 0. It can, the lowest point it can get is 0. Right. So this is 0 plus 5 by 4. So root of 0 plus 5 by 4, that is the lowest one it can get. So when that is happening when y1 is equal to 1, that means this point. When both x and y are equal to 1, this is the shortest distance. This line. When you do a little bit left also it is longer, little bit right also it is longer. So what is the shortest distance? When this is 0, root of 5 by 4. That is root 5 by 2. That is the correct answer. Root 5 by 2. This is the correct answer. Right, guys. We've taken just a random point on this curve and then made it a perfect square because this is a quadratic equation. We converted that into a perfect square and then we figured out that the lowest distance is root 5 by 2. Right, using calculus also we can do. We can differentiate this and then make the derivative equal to 0 and then also we can get the lowest value. Right, and because this distance is a function of y. Right, you can differentiate this and still get to the lowest one. Still get when the differentiation when the value of dy by dx is 0, at that point the distance would be minimum. Right. In this case, we have just used the algebraic way and not calculus way. Hope you like this. Thank you.